Cougars. I hope you're having an awesome day today. We are going to be continuing our journey on algebra and algebraic expressions by looking at the properties of addition and multiplication today. And by the end of our lesson, you should be able to answer this essential question around how do you write equivalent expressions? So we have this idea around expressions, which we know are math sentences, right? So we have equivalent expressions. So we have math sentences that are equivalent. And so we're going to look at what does equivalent mean when it has to do with a math sentence. And so by the end of the lesson today, you should be able to, one, tell me what is an equivalent expression in your own words. Two, you should also be able to tell me what are the properties of addition and how can we use those to generate or make an equivalent expression. And then you should also be able to use the properties of multiplication to create an equivalent expression. So we're going to first figure out what an equivalent expression is. And then two, you should be able to use addition and multiplication to make equivalent expressions. So let's start out with what are equivalent expressions? Well, equivalent expressions are, so this word equivalent expressions are exactly what they sound like. They are equal math sentences. Okay, so we know expressions are math sentences and we know equivalent means the same. So we're going to have math sentences that are the same on both sides of an equal sign. So we're going to have two math sentences that are going to be compared with an equal sign. And it's going to be our job to determine whether or not those math sentences are equal to each other or if they show equivalence. So it is, they are math sentences with an equal sign each side should have the same value. All right, so we have this idea around equivalent. So equal value in a math sentence. So math sentences with the same value. Okay, so you're going to have an equal sign. One side is equal to the other side. Okay, we're going to be looking at two different properties today in order to be able to tell if something is equivalent. We are going to be using the commutative property. The commutative property is one of them, and the commutative property is spelled like this. Commutative property is just the order in which something is written. So the commutative property changes the order that you add or multiply an expression. So it changes the order that you add or multiply an expression. And there are two different commutative properties. We have the commutative property of addition, and we have the commutative property of multiplication. So the way that I like to think about the commutative property is I like to think of it as commuting because it has the word commute in it. So when I commute to work, or when people commute to work, they are driving from one place to another. So when I commute to work, I leave my house and then I drive to work. And then when I go home, I leave work and then I go home. I'm doing the exact same thing, it's just in reverse order. I'm covering the same distance. When you commute to school, if we were going to school, you would be leaving your house and driving on a school bus from home to school. And then from school, when you go home, you go from school back to home. It's the same distance, it's just reverse order because it's a different time. So commutative property, you're commuting, you're just changing the order that you either add or multiply. So we're commuting, we're changing the order that we drive from one place to another. That's the commutative property. You can write the commutative property with numbers, and it looks like this in numbers. In numbers, you can say 5 plus 8. This expression, this number expression, is the same as 8 plus 5. So when I add 8 plus 5, I get the exact same thing as if I were to add, nope, sorry, I knew I said that backwards. When I add 5 plus 8, and then I get the exact same thing as 8 plus 5. So it's the same number sentence. Okay, 5 times 8, so the commutative property of multiplication says that this expression is the same as 8 times 5. Oh no, pen down. Okay, so 5 times 8 is the same as 8 times 5. I get 40 on one side. 40 is the same as 40. They're equal. They are equivalent. Just because I moved numbers around on each side in my expressions, two different expressions, same answer. Because in addition and multiplication, I am allowed to do that. Okay, let's look at what it looks like though in algebra. Algebra! Okay, in algebra, we use letters instead. So in using letters, it's the exact same thing. A plus B is the same as B plus A, because guess what? Those are just placeholders. When I put in a number, A is going to be the same number. So if I said A equals 2, this is a 2 and that's a 2. If I said B equals 3, this is 2 plus 3. This side means 3 plus 2. You get 5 on both sides. 5 is the same as 5. If they had different values for A and B, it would be the same thing. And it's going to be the same thing when you multiply. A times B is the same thing as B times A. They are equivalent. Okay, so when you multiply on one side, you can reverse the order or commute your numbers or letters, and you get the same answer on the other side. They can move around. They can commute. Okay, the other property that I want to talk to you about today is called the associative property. The associative property says that I can not only change my numbers around, because of the commutative property, but I can also change the groupings around. So this one says that I can change the groupings. Oops. I can change my groupings. So I can change what's added or what's multiplied first and still get the same answer. So I can change the groupings of what is added or multiplied, and I am going to get the exact same answer. So this is my associative property. It's associative. This one says change the groupings. It won't change the answer. Okay, so what in the world does this mean? Well, let's look at it in numbers. Let's talk about it in numbers first. So in numbers, this means my pen is dying. That's what it means. No, I'm just kidding. That's not what it means, but that's really what's happening. I have to get a new blue pen. Okay. It means that if I had 7 plus 4 plus 2, that's my expression. I have this numerical expression. It means that it's equal to 7 plus 4 plus 2 if I move the parentheses and solve in here first. I'm going to get the exact same answer. So we know that 7 plus 4 is 11, plus 2 is 13. So this side equals 13, right? Let's move to the other side of the equal sign. So in this expression, 4 plus 2 is 6, and 6 plus 7 is 13. So this is the same as this. 13 is the same as 13. It did not matter which group of numbers we added first. We got the same answer because the associative property of addition says we can move our groupings and get the exact same answer. It works with multiplication too. Watch. 7 times 4 times 2. Let's say that on this side, I multiply there first, and on this side, I multiply here first. All right. I know that 4 times 2 is 8, right? Times 7, I'm going to get the exact same answer as if I did it over here. 7 times 4 times 2. It doesn't matter what order I multiply in. I'm getting the exact same answer. All I did was move my grouping symbols around. Okay, so I just keep moving those grouping symbols around. Okay, so 8, 56, 7 times 4 times 2, we still get 56. It doesn't matter. This expression is the same as this expression. Okay, let's look at what it means in algebra. Algebra. Okay, in algebra, when we throw in some letters, what does it mean? In algebra, it means that if I say A plus B plus C, if I add it in that order, I will get the exact same thing if I did it as if I did B plus C first and then added A. It's the exact same answer. It does not matter. Okay, same thing with multiplication. Because again, I am substituting A times B times C. Boom. If I multiply those two first, I would have to then multiply this one just like we did over here. Those are placeholders. This algebraic expression is the same as this algebraic expression over here. A times B first times C. It does not matter. It doesn't matter. Okay? Because once we substitute in numbers, it doesn't matter. Okay, now let's see this in action. Let's do an example. Okay, so let's do example A. How do we solve this when we have some letters and some numbers? Let's do some simplification and let's see this thing in action. All right, so I have a problem and it looks like this. 7 plus 12 plus x. I want to write an equivalent expression. I need to write an equivalent expression. Well, I cannot write an equivalent expression by adding 12 and x. 12 and x may not go together because I do not know what x is. They don't give me a value for x. So I can move my grouping symbols around. So what I'm going to do is I'm going to move my grouping symbols around so that I can find a simplified version of this problem. So what I'm going to do is I am going to take this problem and I am going to rewrite these terms. I'm going to write the 7, the 12, and the x term. Now, I am going to use the associative property of addition, and I am going to move my parentheses. I am going to move my parentheses right here around the 7 and the 12. I moved them there so that I can combine those numbers. Because numbers and numbers are like terms, I can put them together. So 7 plus 12 is 19. I can combine those. So 19 plus x. Right there, I can stop now. 19 plus x. I am done. I have used the associative property. Property of addition. I use the associative property of addition to move my parentheses. They like to move it, move it. They like to move it, right? We moved it, and then we simplified. Boom, done. We did all of that just in one problem. And look, 19 plus x is the same as 7 plus 12 plus x. This expression is the same as 19 plus x. All I did was simplify it down by using the associative property. Okay, let's do another one. Okay, example B. All right, we have 10 plus C plus 9. All right, what can go together in this problem? Well, we can see that numbers can go with numbers. So I actually have to use two properties in this example. I'm going to be using the commutative property and the associative property. I'm going to move my 9 and I am going to move my parentheses. All right, so I'm going to say this expression is the same as 10 plus 9 plus c. I'm just going to be adding those ones first. And again, apparently, I get 19. I like 19 today. And I get c. I've used the commutative property of addition. And then I simplified. I moved some stuff around. Again, I moved it, right? And then I simplified. This expression is the same as this one. Nothing has been lost, and they both equal the same thing. Okay, let's do a multiplication problem since we haven't done one of those yet. Let's do a multiplication problem. Again, with my pen that's dying. Okay, so we have 5 times, because remember, a number stuck to parentheses means to multiply. 11y. Oh, a number stuck to a letter means to multiply. Look at all that multiplication happening in there. Is the same as what? Well, let's rewrite this. So 1, we know that it's all multiplication, and then let's move some stuff around. All right. So let's say that we have 5 times 11 times y. Okay. Now we can move these parentheses around so that we can have them around the 5 and the 11, so that way we're multiplying. Because really this is like a 1y. That's like a 1y. Okay? So when we're looking at this, if we just move these parentheses, so it says 5 times 11 times y, we get 55 times y. So we get 55 times y. We used the associative property of multiplication because we multiplied, so it's associative property of multiplication, and then we simplified. All right, we didn't have to move any numbers around. All we had to move were our parentheses. Here we had to move numbers around. The numbers had to commute. Our terms had to commute. The terms commuted. Here, no terms were commuting. It is time for you to try it. All right, I want you to do a try it. All right, try it. I would like for you to do 6 times x times 7. Simplify. Make me an equivalent expression. Okay, but first, you need to hit pause. Otherwise, you will not be able to check your own understanding right now. And if you don't check your own understanding, you will have no clue where you are at with your learning. So hit pause so you don't hear my voice anymore. Hit it. Okay, so I need to move my numbers around. So I am going to move this 7 around. So I am going to say 6 times 7 times x. And then I'm going to put parentheses here, and I get 42 times x. Or I could say 42 times x, like that. All right, out in the corner. So you should have 42x, or you could write 42 times x, whichever one you prefer. Out here, please tell me what your understanding is. How are you feeling about this right now? Document your learning. How are you feeling about using these properties? How are you feeling about moving numbers around? How are you feeling about simplifying like terms together? Putting numbers with numbers, letters with letters? And then answer this question for me. How do you write equivalent expressions? So somewhere on your paper, answer your essential question in your own words. And then when you are done, you may head on over to your practice work. Thank you for your hard work today, and always make it a great day the Cougar way.